Welcome to our channel. In today's critical video, we're confronting a deeply concerning issue in IVF treatments: the increased cancer risk in children born through frozen embryo transfer. Startling recent research points to a risk comparable to living in highly radiation-polluted areas. Yet, shockingly, this information hasn't resonated as widely as it should in the fertility community. Our goal today is to bring this vital conversation to the forefront. We'll dive into the detailed studies revealing this risk, exploring the statistical data and biological evidence behind these harrowing findings. We found not just a single research study, but a whole body of evidence suggesting a strong likelihood of a cancer predisposition for future child if you use frozen embryo transfer. Here's why. First, there is strong statistical epidemiological evidence showing a 42% increased cancer risk in children born after frozen embryo transfer compared to those from fresh embryo transfer. This conclusion is based on a meta-research comprising all available papers up to 2020, involving about 25,000 children, which showed a 28% increase, and the latest research from 2022 on about 22,000 children indicating a risk increase of 56%. Therefore, we can consider the average increase in cancer risk to be about 42% based on data from around 48,000 children, the sum of all available data as of now. Despite the low absolute number of cancer cases in these studies, the fact that the results are statistically significant even after adjustments for known childhood cancer factors makes these results quite reliable. The likelihood of these findings occurring by chance is very low, especially considering that no research study has presented an opposite conclusion and that the effect sizes are very consistent across different papers. Also, the comparison between frozen and fresh embryo transfers means that factors like infertility-related health conditions can't be an alternative explanation for the observed results. To put this risk in context, consider the comparison with living in severely radiation-polluted areas. According to the study Background Ionizing Radiation and the Risk of Childhood Cancer, areas with over 200 nanosieverts per hour of background radiation, the highest in research, see a 64% increase in cancer risk compared to less polluted areas. This frightening parallel shows that, even in case we agree that the risk from frozen embryo transfer is currently only suspected, its potential magnitude, nearly matching the risk from the highest radiation exposure, is deeply concerning. In our research, we found one study seemingly showing no cancer risk difference between frozen and fresh embryo transfers. However, a closer look reveals it actually concerns oocyte cryopreservation, a detail clarified in the study's supplementary tables. Indeed, the research on oocyte cryopreservation shows no statistical difference in childhood cancer risk with fresh embryo transfer, which again points to genetic damage caused by embryo cryopreservation. Because in the case of oocyte cryopreservation, half of the genetic material, the father's sperm, is intact, not cryopreserved, which gives the embryo the undamaged set of genetic material. To test this hypothesis, we need to look for biological evidence of genetic damage. It turns out there are indeed at least two proven biological mechanisms explaining how vitrification can lead to cancer risk. Vitrification leads to genetic damage, found by numerous research papers. These, for example. And vitrification interferes with epigenetics, found by numerous research papers as well. So, of course, we still can suppose that it is possible that statistical evidence alone could just be a data artifact or statistical glitch. The biological evidence alone could have an alternative explanation as well. The damage may exist but be insufficient to cause serious problems. But it is very hard to dismiss these two pieces of evidence together. Consider it like a judge in court. Individually, each piece of evidence might raise questions, but together, they form an undeniable conclusion. It's like having both fingerprints at the crime scene and a credible witness testimony. Each supports the other, making the case much stronger. In our case, the combined statistical and biological evidence compels us to acknowledge the significant risk. So the childhood cancer risk is, most likely indeed, elevated by 50% in frozen embryo transfer, born children. So, there are two possibilities. If this damage influences the specific causes of childhood cancer, we are talking about only the childhood cancer risk. So a 50% increase in relative risk translates indeed to a negligible increase in absolute cancer risk and poses no problem. But here is a main concern. If this damage influences some general anti-cancer abilities of the human body, like the p53 gene for example, or other general cancer-inducing factors, and that is how it increases childhood cancer risk, this is a disaster. That means it increases by 40% the lifetime cancer risk, which is an enormous effect and overlaps pretty much all possible lifestyle choices to minimize cancer risk during life. As we mentioned before, it is comparable to severe childhood radiation exposure effect. As parents, how will we teach our child to make choices maximizing life expectancy, rely on evidence, and calculate probabilities to make decisions, knowing that we deliberately increase their cancer risk by 40% in the first place? That is an awful starting position for the future child, isn't it?